So the last thing that we have seen, as I remember, the last thing that I've seen, we have started with summarization. Okay, so we'll keep summarization a bit apart. Okay, we have seen how to summarize a network. We have seen the concept of summarization, how summarization works. Now let us move to our routing protocols. Okay, so what are routing protocols that you know? What are the routing protocols? If I say routing protocol, what are the main types of routing protocols? The main types of routing protocols I know is static and dynamic. Okay, the main types of routing protocols are static. Static is been configured by administrator. Configured by administrator. Okay, the best path is selected by the administrator only. Whereas dynamic is something that we will learn in more. We have seen the static routing. So when I say dynamic, dynamic has two main parts. The first one is IGP, Interior Gateway Protocol, and the second one is EGP, Exterior Gateway Protocol. Correct? In IGP, again, I have two main lists over here. I can make it three also. Okay, but let it be two. Distance vector and link state. In distance vector, I have some routing protocols. That is, some routing protocols are there. In link state also, I'm having some routing protocols. So in distance vector, the first one is, I can say, rep. Then I have IGRP, which are no more used. Then I have EIGRP. Now EIGRP is also known as advanced distance vector or hybrid protocol. Okay, but it comes in distance vector only. It is also known as advanced distance vector. So I can make it three parts over here if I want to make, and I can include EIGRP over here. Okay, in the third part, that is my third one is my hybrid. So in hybrid, I have EIGRP. I have only one protocol, that is EIGRP. Okay. Then in link state, I have OSPF and ISIS. So as per our syllabus, we'll be only learning about EIGRP and OSPF. Because RIP has been removed. Okay, RIP is no more used. Okay, it has been removed because it is for small organization. It is used for small organization only. Now this is the tree of routing protocols, and if I go in EGP, I have only one routing protocol, that is BGP. Okay, sometimes it is also known as path vector. Okay, sometimes it is also known as path vector, sometimes it is known as BGP. Got it? Now we'll start with EIGRP first. We'll start with EIGRP. So what is EIGRP? Enhanced Interior Gateway Routing Protocol. Advanced Distance Vector or Hybrid Protocol, you can say. It is an hybrid protocol. So I have some notes prepared by me on EIGRP. So we can go through that notes. It is Advanced Distance Vector Protocol or Hybrid Protocol. It is a standard protocol. Previously it was Cisco proprietary. Now it is not a Cisco proprietary. It is a classless routing protocol. Classless means it has a support for FLSM, VLSM, and all these things. Okay. So if we do subnetting, then also it will support our subnetting as well. Then maximum hop count that it supports is 255. You can have 255 hop counts. Okay. In RIP, you are having just 15 hop counts. Okay. Then the default hop count that EIGRP supports is 100. You can change this hop counts. Okay. Now the AD value, the administrative distance value for internal routes in EIGRP. Internal routes means within the same autonomous system is 90. Coming from another autonomous system, the administrative distance will be 170. The summary routes will be having the administrative distance as 5. Okay, so these are the administrative distance in EIGRP. For internal routes for within the same autonomous system, it is 90. The routes that are coming from external autonomous system, that is 170. Summary routes are having the administrative distance as 5. You can have flexible network design with EIGRP. It uses multicast instead of unicast and broadcast. It uses multicast. 100% loop-free routing protocol. Updates are sent through multicast address 224.0.0.10. Hello packets are sent every 5 seconds. Okay. Convergence is very fast. If one link goes down, it automatically it selects successor and feasible successor both. If the feasibility condition matches, it will automatically select the feasible successor as well. It supports equal as well as unequal cost load balancing. Equal cost load balancing means if we have multiple uh, path to reach the destination and all the paths are equal, then by default EIGRP will do equal cost load balancing. But unequal cost load balancing, it is not by default. We have to manually configure it. We have to manually configure it. Okay, this is something EIGRP. Now these are some components that are there in EIGRP PDM, protocol dependent module. Okay, then we have RTP. RTP is something that is used for delivery of each packet. It will ensure that updates are delivered quickly and data is tracked accurately. RTP protocol, reliable transport protocol. Then we have NDP, neighbor discovery protocol. Neighbors are discovered using NDP. Then it uses DAL algorithm, diffusion update algorithm. Okay, the algorithm that selects the best path. Okay. See, these all things we have already studied at the CCNA level. I'm just giving you a quick revision of these all things so that you can brush up your mind. Then requirements to become a neighbor in EIGRP. If two routers want to become a neighbor, these are the requirements. All the routers should fulfill these requirements. First, the router should be in the same autonomous system, same AS. The K value should be same. If we are configuring any authentication, the authentication should be same. Okay, so these are something, and EIGRP supports MD5 authentication. MD5 authentication is a key digest in each EIGRP packet, prevents the introduction of unauthorized or false routing messages from unapproved sources. Okay, so EIGRP supports MD5 authentication. Okay, then if I go to the process of EIGRP, how EIGRP works, step by step process for EIGRP. Yes, there it is. So we have 5 types of packets over here. Hello packet, update, query, reply, and acknowledgement. So whenever I advertise any interface or any network inside EIGRP, any network inside ERP, EGA, not interface, any network inside EIGRP, it will send an hello packet on the multicast address. Okay, it will send an hello packet on the multicast address. I am router A who is on the link. If suppose I have advertised router A and router B both with EIGRP, both the networks with EIGRP, then router B will receive this multicast hello packet and it will send a reply. Hello, I am router B. Okay, hello, I am router B. And with after the hello packet, it will send an update packet. It will send complete routing information, complete routing table. Router B will send complete routing table of its own. Okay, so now router A will get the routing table, and router B will come, router A will send an ACK packet, acknowledgement packet, that thanks for the information. And after the ACK packet, router A will also share its routing table. Okay, now router B will send an acknowledgement packet, and both the routers will be converged. They will be neighbor. Okay, they will be neighbor with each other. Now here we have three tables: neighbor table, topology table, and routing table. Now what is neighbor table? List of directly connected neighbors. Neighbor table means list of directly connected neighbors. What is my topology table? Topology table will be collecting the best route, and it will be it will be having best route and the second best route. If EIGRP has selected the feasible successor, it will be having the second best route as well. Routing table, as we know, routing table has only the best route installed in it. Okay, so suppose if I give you an example over here, I have three neighbors, router A, I have three neighbors over here. This is my router A, this is my router B, this is my router C, and this is my router D. I want to reach a network 50 dot network, and I have three paths from A. I have three paths to reach the network. Suppose there is some network over here. So if if suppose B will say, if you want to reach some 50 dot network, suppose over here 50 dot network, I have four possible paths to reach the 50 dot network. C will say, suppose if you will go via me, I have three possible path. D will say, I have two possible path. This 4, 3, and 2. These all paths will be stored in the topology table. Okay, these all paths will be stored in the topology table. And among these paths, what will be the best path will be stored in the routing table. Okay, so this is something EIGRP tables. See, we have already seen these things at the CCNA level. Okay, then we have K values. Metric is calculated on the basis of K values. Now, K values consist of bandwidth, delay, load, MTU, and reliability. Okay, so by default, EIGRP will only select bandwidth and delay to calculate the metric value, to calculate the best route. Okay, so by default it will select only bandwidth and delay, means bandwidth and delay will be 1 1, others will be 0 0 0. Load, reliability, and MTU will be 0 0 0. You can change these values at any time you want. Now these are some default values that are given. Okay, the bandwidth, what is bandwidth? Bandwidth is speed of the link, width of the link, you can say, width of the link. So for serial link, the default bandwidth is 1544 kbps. For fast Ethernet, 100 mbps. For gigabit, 1000 mbps, or you can say 1 gig. Delay, the amount of time it will take to forward the traffic. For serial link, it is 20,000 milliseconds. Fast Ethernet, 100 milliseconds, sorry, microseconds, not milliseconds, microseconds. Gig, it is 10 microseconds. Okay, so this is something by default values that are given. MTU, maximum transmission unit, how many bytes it can transmit. So it is 1500 bytes by default Okay. Now reliability is something like status of the link. It is calculated between 1 to 255. 1 is not reliable, 255 is most reliable. Load, amount of traffic moving on the link. Amount of traffic that is moving on the link, that is calculated between 1 to 255. Okay. Load, 1 means less and 255 means more. Got it? Now this is the formula that is being used to calculate the metric value, 10 raised to 7 by bandwidth plus delay divided by 10 into 256. Okay, so this is the formula that is being used to calculate. See, the formula is written in different ways, like K1 into 10 raised to 7 by bandwidth plus K2 into bandwidth upon 256 minus load plus K3 into cumulative delays. Okay, but I have simplified this formula and the formula becomes 10 raised to 7 by bandwidth, because we don't need the values of load and delays. Then, sorry, load and reliability and MTU, all these things. Then delay by 10 into 256. This is the formula that is used to calculate the metric value in EIGRP. Understood? Now we have load balancing. Now equal cost load balancing is there if the metric is equal. Okay, if the metric is equal, if I say equal cost load balancing, if the metric is equal on all available paths, then it does equal cost load balancing by default. Okay, equal cost load balancing. Then I have unequal cost load balancing. Unequal cost load balancing means if the metric is not equal, then also we can do load balancing by using a concept in EIGRP, concept of variance. So we'll study about this variance concept and all these things, okay, in the further lectures. Now we have Deol algorithm. Now before moving to the Deol algorithm, there are some concepts. Feasible distance. What is feasible distance? Anyone? Okay, so feasible distance is something, if suppose A is my source in this diagram and F is my destination, I have 3 paths. Feasible distance means total cost from my router to the destination router. If I go via B, the feasible distance will be 2000, 1000 and 1000. If I go via C, the feasible distance will be 3000. If I go via D, the feasible distance will be 2 to 4 plus 3, 7000. Okay, this is my feasible distance, total cost from local router to the destination. See, these are the two main concepts in EIGRP, feasible distance and advertised distance. Advertised distance, cost from next hop router to the destination. So advertised distance means B is my neighbor. B is advertising me. If you want to go to F, you can go via me. The cost is 1000. B is advertising the cost from his end. From B, the cost is 1000. From C, the cost is 1500. From D, the cost is 2000 plus 3000, 5000. This is my advertise distance. The neighbor, that the cost that is being advertised by my neighbor, that is known my advertised distance, or sometime it is also known as reported distance, RD, reported distance. Okay, so this is something my feasible distance and advertised distance. Now EIGRP also pre-calculates the second best route if satisfies the feasibility condition. Now there is a condition. If it satisfies the condition, then and only then it will select the second best route as well. Okay, so second best route will be, if the first route fails, then the automatically it will converge, it will select the second best route. What is the feasibility condition? Feasibility condition says FD of successor, feasible distance of successor, should be greater than AD of feasible successor. Okay, so if this condition matches, then and only then it will select the feasible successor. Okay, so in our condition, this is the best route because it has the lowest feasible distance. Now to calculate the feasible successor, I need to check this condition. FD of the successor is 2000. Now, how many routes I am having? I am having two routes remaining to reach the destination F. One is having the advertised distance as 1500 and another one is having advertised distance as 5000. So which route you will select as the feasible successor? I'll not select this route. The route via C, ACF will be my feasible successor. Understood? This is something my feasibility condition. So here I have two routes and one of the route is matching with the feasibility condition. It is the feasibility condition is getting fulfilled. So what I'm doing, I'm selecting the second best route as well over here. Okay, got it? Any questions still here? Okay. Now we can quickly go and we can configure EIGRP. Router 1, router 2, router 3, and router 4. So I have IP addresses, as you can see on the screen. I have pre-configured IP addresses on all the routers. Show IP interface, show IP interface brief. So I have loopbacks also configured on each of the routers. So here I am having some 11.loopback, 11.0.0.1. Then I have 11.0.0. Sorry, 1.1, 11.0.2.1, and 11.0.3.1. All are /24. All are /24. Here I am having on R2, I am having 12.loopbacks, 12.0.0.1 /24, 12.0.1.1 /24, 12.0.2.1 /24, and 12.0.3.1 /24. And on R3, I have already given over here. On R3, you can see on R4, I am having loopbacks 14.0.0.1/24. Then I have 14.0.1.1/24, 14.0.2.1/24, 14.0.3.1/24. Okay. Now, if I show you the loopback addresses over here on R1, and between R1 and R2, I am having one dot network. R1 LAN is 10 dot network. R2's LAN is 20 dot network. R3's LAN is 30 dot network. R4 LAN is 40 dot network. Okay. Show IP interface brief. IP addresses configured. Show IP interface brief. Configured IP addresses. Show IP interface brief. Pre-configured IP addresses. Show IP protocol. There is no protocol running on any of the router. Okay. So how I can configure EIGRP? If I try to ping 1.1.1.2, I am able to ping. But if I try to ping the loopback on R2, or if I try to ping the LAN interface, I'll not be able to ping. Okay, so I'll turn on some debug packet, debug EIGRP packets to see the EIGRP flow. Okay, I've turned on the EIGRP packets. Now to configure EIGRP, I need to say config terminal. I have to say router EIGRP and the autonomous system, router EIGRP 100. And I need to advertise the network. I'll advertise my LAN and my WAN. I'm not advertising the loopback addresses for now. Now you can see over here, I'm getting some messages. Hello on fast Ethernet 0/0. Hello on serial interface. Hello on serial interface 3/0. Hello on this interface. It is sending hello messages. Okay. If I see show IP EIGRP, sorry, show IP EIGRP interfaces. Okay, it is telling me I am EIGRP. I'm running on two interfaces over here. Okay, I'll turn on debug EIGRP packets on R2 as well. I've turned on R2 as well. Okay, I'll configure R2 as well for EIGRP. I'll say router EIGRP 100. See, I'm putting both the routers in the same autonomous system network, my LAN network and my WAN network. See, hello, and I'm getting update packet, ACK packet. You can see I'm getting hello packet, I'm getting update packet, I'm getting ACK packets over here. Hello packet, hello packet. See, it is sending hello packet. Okay, here also I will be receiving hello packets. Okay, so here I will show you the ACK packets as well. See, update packet. Let me turn off the debugging. CAC update packet, ACK packet, ACK packet, update packet. So these are the packets that are being exchanged between EIGRP if you configure two routers with EIGRP. If I see show IP EIGRP neighbor, this will give me the neighbor table. I have formed a neighborship with 1.1.1.2. Okay, I formed a neighborship with 1.1.1.2 over here. If I try to ping 20.1.1.1, I am able to reach the LAN of the R2. Now, if I want to increase the hop count, as I told you, EIGRP has a maximum hop count bytes as 100. Okay, so if I want to increase the maximum number of hop, what I need to say? I need to go inside the router EIGRP 100 and I need to say maximum paths. Okay, I can select over here. I'm not getting the options of 255 here. I will, because this is something a simulation. Okay, so that is the reason I'm not getting the things over here, but in the on the real router you will be getting the things properly. Okay, now load balancing, as I told you, it does equal cost load balancing by default. Routes with lowest metric get installed in the routing table by default. Now, if two or more routes with same metric installed, okay, both the routes in the routing table and does load balancing. It keeps both the routes in the routing table and it does load balancing. Okay, this is called equal cost load balancing. Now, it does equal cost load balancing automatically. For unequal cost load balancing, we need to enable unequal cost load balancing. So if I go in unequal cost load balancing, or if I first configure all the routers to run EIGRP router EIGRP 100, and I'll say network 30.network and 3.network and 2.network. On R2 also I have to configure 2.network. I need to advertise the 2.network because I have not advertised the 2.network on R2. Okay, so it will form a neighborship. The neighborship will come up with R3 over here. Then I have on R4, I have router EIGRP 100 network, 40.network in my LAN network, 3.network, 4.network. Okay, on R1 I need to advertise the 4.network as well. So it will form the neighborship with the router. Now you can see, if I see show IP route EIGRP to reach the 30.network, I am having two paths. I can go via R2, I can go via R4. I am having two paths and both are installed in the routing table. Okay, both are installed in the routing table. Got it? Now, equal cost and unequal cost load balancing. This is something equal cost load balancing which is done by default. Now, if I have unequal cost, EIGRP also supports unequal cost load balancing. We have to do this manually. We have to do this manually. Now, with the help of variance command, now there is some calculation that is done. The calculation is given over here. Cost of successor multiplied by variance. Whatever can be the variance value, it should be greater than the cost of the other routes to be used in load balancing. So if I take the example of this route, let me take it to paint over here. Okay, just see this diagram. So I have multiple routes to reach the destination. This is my source, this is my destination. I have three routes and just see the feasible distance over here. Okay, don't see the advertised distance, just see the feasible distance. So if I go, I am having unequal paths over here. I'm running EIGRP. I want that it should use unequal, it should use all of the paths, or it should use two of the paths to send the traffic. So by default, it will only send it via this path because only one route will be installed in the routing table. Okay. And if we want that A, B, F and ACF both should get installed in the routing table, then we have to calculate something. Cost of successor. What is the cost of successor? Cost of successor is 1000 over here. Cost of successor is 2000. Sorry, not 1000. It is 2000. Cost of successor is 2000. Multiplied by variance value. Any variance value should be greater than the cost of other routes. So what is the cost of other routes? 3000 and 7000. There are two costs over here. Now I want ABF and ACF to be done. Now how I can do these things? Unequal cost. So the default variance value that is there is 1. Okay, so if I multiply any value with 1, 2000 will only be 2000. Okay, so which is not fulfilling my condition. Cost of successor should be greater than the cost of other routes that you need to be. So I am only considering 3000 ACF. So let us only take ACF. So if I multiply it by 1, which is the default variance value, it will not give me it will not fulfill the condition. So what I need to do, I need to increase the count of variance. So I will increase the variance value as 2. Now when I increase the variance value as 2, the feasible successor cost will become as 4000 now. The feasible successor cost will become as 4000, and the cost over here is 3000 for other route. Correct? Now the condition is fulfilled over here. Cost of successor, the variance condition, the unequal cost condition is fulfilled over here. Cost of successor into variance is greater than cost of other route used for load balancing. Now here I need to change the variance value. When I change the variance value, okay, what I got, now I can send the packets from both the paths. Now I can send the packets from both the paths. Now it will do unequal cost load balancing. Now what it will do? Unequal cost load balancing. This is something load balancing in EIGRP. This is something variance command in EIGRP. How you can change the variance value? You can go inside the router EIGRP mode and you can just give the variance command. Okay. So we'll see the thing, we'll see practically. Now I've shown you about equal cost load balancing. I've configured the EIGRP. I've shown you the equal cost load balancing. Okay, you can see from the output on the screen, we can see that the router R1 install both the routes in the routing table as it is using both the routes to reach the R3's network, R3's LAN, that is 30.1.1.1. Now R1 does equal cost load balancing between two routes via R2 and R4, and both the routers are having equal cost to reach the network. Correct? Now if I want to check, if I will check the show interface serial 3/0 that is connected to my R2. I can get the default values. You can see the bandwidth value is 1544 KB. Okay, 1544 KB over here. Now the bandwidth is set primarily to provide the correct composite metric factor and a realistic and true description of the available bandwidth on the interface. Now it is also set to prevent EIGRP from flooding the interface. So by default, EIGRP uses up to 50% of bandwidth that the interface reports, okay, to the Cisco iOS software. Now suppose there was a significant routing instability in some other part of the EIGRP autonomous system. If EIGRP were to use 50% of 1544 kbps for its own routing information traffic, EIGRP would fully, you can say, saturate the low bandwidth 64 kb per second serial link. Okay, so for EIGRP, make an accurate computation. Okay, so now seeing the unequal cost load balancing, what we need to do, we can change the bandwidth. We can change the bandwidth over here. Okay, so what I will do, I'll assume that the bandwidth on the WAN link between R1 and R2, that is serial 3/0. Okay, I'll make it as 1000 kbps. Okay, from the, I'll make it as 1000 kbps. Now I'll change the bandwidth to 1000 kbps between the link R1 and R2. Now this also makes both the routes as unequal, and we can implement and verify unequal cost load balancing. So let us do how we can change the bandwidth interface serial 3/0. I need to say bandwidth and I'll say 1000 kbps. Okay, that's it. I'll go on R2 as well and I'll say interface serial 3/0 and I'll say bandwidth is 1000 kbps. Got it? Now if I go in R1 and if I see show IP EIGRP topology, here I can see the topology table. One successor route and the other one is the feasible successor. The successor one is the successor route via R4, okay, which is having the lowest cost, lowest metric value, you can say. Okay, then the other one is my feasible successor, which is installed in the routing table. Okay, so the FD value you can see over here, the FD value, feasible distance value, is 26,84416. This is the FD value over here. Okay, FD value of both the routes are different because we have changed the bandwidth. So now my traffic is moving via R4. Now my traffic is moving via R4. So if I try to trace route 30.network, my traffic is going via R4. Okay, that is 4.4.4.2. Okay, that is using this interface 4.4.4.2. Okay, because I have changed the bandwidth. So I am having feasible successor also. Now I will configure R1 to do unequal cost load balancing between the two routes which are available to reach the 30.network. Now once we change the bandwidth on, you have to make a note of this. Once we change the bandwidth on R1 interface, we can see the EIGRP prefers only one route with the better cost. Okay, EIGRP also supports unequal cost load balancing, but it has to be done manually using variance. Okay, so variance is multiplier value ranges between 1 to 128 and default is 1. So if you want to see the variance value, you can give the show IP protocol command. Here you will get the variance value. See, EIGRP maximum metric variance is 1. So by default, the maximum variance value will be 1. So as per our example in our lab, okay, the cost of successor. What is the cost of successor over here? Show IP, sorry, not show IP protocol. Show IP EIGRP topology. What is the cost of successor? The cost of successor is this 264416. Okay. So I'll take it in the notepad. paste 26. What does the condition says? Cost of successor multiplied by variance value should be greater than the cost of feasible successor. This is my feasible successor. Okay, so the cost of successor is 26,84416. If I multiply it by 2, what will be the value? The value will be something 52 something. Okay, the value will become 52. Okay, so deciding the variance value which satisfies our condition. So if I multiply it by 2, I will get a number greater than 35. Okay, so it will be something 52 something. So what I will do, I'll make the variance as 2. I'll make the variance value as 2. So to change the variance value, I need to go on router 1 and I need to say router. I need to go inside EIGRP and I need to say variance. And here I am having a value between 1 to 128. As per your cost, you can choose any value. As per our example, our lab, I am using the variance value as 2. Okay. So now if I see show IP protocol, here you can see EIGRP maximum. Sorry. Here you can see the metric variance value is how much now? EIGRP maximum metric value is 2. Okay. If I see show IP route EIGRP, see for 30 dot network, I am having two possible routes. For 30 dot network, I am having two possible routes with different cost. You can see I'm having two possible routes for 30 dot network and both are having different cost over here. You can see on R1. Okay, so it is doing unequal cost load balancing. If you need to verify, see one packet is sent via R4, one packet is sent via R2. Got it? So it is doing unequal cost load balancing over here. It is doing unequal cost load balancing. Understood? Any questions, guys? Hello, Nilesh, can you hear me? I guess. Hello, Nilesh, I guess, can you hear me? Nilesh, can you hear me? Okay, no issues. So this is something my EIGRP does. Unequal cost load balancing. Okay. Now we have some concepts, more concepts about EIGRP. Okay, like we have EIGRP stub. Okay, so first of all, what is EIGRP stub? So Why we need EIGRP stub? Why we need stubs in EIGRP? So if you remember the condition over here, the feasibility condition, what we have studied, okay, if you remember the feasibility condition over here, I have told you that we have 5 types of packet: hello, update, query, reply, and acknowledgement. We have only seen hello, update, and acknowledgement. We haven't seen reply and query packets yet. So what will happen if I change the cost over here as 2500? Now the advertised distance will become over here as 2500. Now let us see the feasibility condition. Feasibility condition says, sorry, FD of successor should be greater than AD of my feasible successor. FD of successor should be greater than AD of the feasible successor. So what is my FD over here? FD is 2000, and I have two possible routes. I have 2500 and I have 5000 over here installed in my table. Okay, now is the condition matching? Is the feasibility condition matching over here? No, it is not matching. So in this type of situation, I will be only having a successor route. I will be not having the EIGRP will not select the feasible successor. Why? Because there is no, the feasibility condition is not matching, it is not fulfilling. So if feasibility condition is not fulfilled, it will not elect the feasible successor. It will not elect the feasible successor. Okay, so now what will be the scenario if my this link goes down? What will happen if my this link goes down? Now my EIGRP needs a route to reach F. So what it will do? It will send a query packet on all the connected neighbors. It will send a query packet to all the connected neighbors. Okay. Now all the connected neighbors, in the sense, if suppose there are some end routers connected over here, end locations connected over here, some branch offices are there, they are connected over here, some end locations. Now these routers will also get the query messages. Now these router does not know how to reach F. Okay. Now these router does not know how to reach F. Now it will get a reply packet from these two routers. Okay, it will get a reply packet from these two routers. Now if the successor path is lost and no feasible successor is identified, the router sends out query on all the interfaces in an attempt to identify an alternate path. Okay, so no successor can be chosen until the router receives a reply from to all the queries. So it has sent to the end locations also. Now it will never receive uh, reply from the end location, because they don't know where is F. So until all the neighbors will reply, all the query messages are replied. If a reply is missing for 3 minutes, the router becomes stuck in active. The router will go into stuck in active, SIA, stuck in active state, if the reply is missing. Now what the router will do in that case, if it will reset the neighbor relationship with the neighbors that did not reply. So what the router will do over here now, it will reset the neighborship from these three interfaces, from these three routers. Okay. So it will reset the neighborship from these three neighbors. Now again it will send a query packet. So it will be in a stuck in active state. There is no use to send a query packet over here because I know that I will not get a reply. Okay, I'll not get a reply from these routers. Okay, so in this type of situation, we need a stub to be configured. Stub routing is one way to limit queries. Okay, what is stub? Stub is a way to limit the queries, limit the query messages that are being sent. Understood? Now, what we need to do, a stub router is, what is a stub router? A stub router is one that is connected to no more than two neighbors and should never be a transit router. It should never be a transit router. Okay, so the EIGRP routing feature improves network stability. It reduces resource utilization and simplifies remote router. Okay, configuration. That is, you can say spoke router if you have spoke. Okay. Now, stub routing is commonly used in hub and spoke topology. Like you know that you will not get a reply from any of the routers. So what you will do, you will say that do not. You will say you will make these routers over here as stub routers. Okay, so you will make these routers as stub routers. So if you make any router as stub router, then this router A will never send a query packet to stub router. So if it will not send a query packet, it will not wait for reply. And once it get a reply from D and C, it will move, it will select a successor route. Okay. Understood. That is why we need EIGRP stub over here. EIGRP stub over here. Okay, so EIGRP stub will say if you make any router, it's a stub router, it will limit the query packets. Okay, so we'll see the configuration of stub, how to configure stub. Now I will only take R1, R2, and R3 as my routers over here. I'll not include R4. Okay, R1, R2, and R3. Now I'll configure I have already configured EIGRP on R1, R2, and R3. I'll disable auto summary. Okay, so I have not disabled the auto summary. So what I'll say, I'll disable the auto summary over here. Router EIGRP 100. I'll say no auto summary. No auto summary. Router EIGRP 100. No auto summary. No auto summary. I'm using R1, R2, and R3 only. Now I have advertised uh, all the networks. Now I will only use one summary route. Okay, must be advertised to R1 and R2 from R3. I'll just advertise on R3. I'll advertise the loopback interface as well. So I'll say network 13.0.0.0. Just on R3, I'm advertising the loopback interfaces. If I see show IP EIGRP neighbor on R2, I'll be having two neighbors, 2.2.2.2 and 1.1.1.1. Okay. 2.2.2.2 and 1.1.1.1. Okay. Now if I see on R1, if I see the routing table, show IP route EIGRP. Here I'll get 13.network as my individual routes. I am getting the 13.network as my individual routes via R2. Okay. So now what I will do, I'll make this routes as summary routes. Okay. I'll make the summary routes over here. On R3, I'll make these routes to be summarized when it is sent outside the router. Okay. Now I will make these routes as summarized routes. Okay, so how to make the summarized route? I'll say when the routes are going outside the interface serial 3/1. When the routes are going outside interface serial 3/1. Okay, serial 3/1. Summarize the route. So to summarize the route, I'll say IP summary address. If I summarize the route EIGRP 100, if I summarize the route, I'll get a summary address as 13.0.0.0 255.252.0. Okay, this will be the summary route. So if I say exit over here, and if I go to R2 and if I check show IP route EIGRP, here I am just getting the 13.network with the slash value as 22. Okay, with the slash value as 22. Now I will configure EIGRP stub on R3. Okay, preventing R3 to send any routes to R2, but R2 receive routes from R1. So what I will do here, I'll make this router as stub router. Okay, and what I will do, I'll say do not send any route to R2, but R2 will receive routes from R1. R2 will receive routes from R1, but it will not get routes from R3. Okay. So to configure stub on R3, I have to go in the EIGRP mode, router EIGRP 100, and I'll say EIGRP stub. EIGRP stub. Now I have different options over here. I have different options over here. I have options like I have connected, I have leak map, I have received only, redistributed route, static route, summary routes, which type of routes you don't want to advertise. Okay, so I have receive only, connected, static, summary. So I want that it should not advertise receive, it should not, it should only receive the routes. R3 should receive the routes from R2, but it should not send the routes. So I'll say receive only. It should receive the routes, but it will not send the routes. Okay, so set IP EIGRP as receive only neighbor. Okay, this is the configuration. If I see show IP show IP route EIGRP, I am getting 1 dot network, 20 dot network, 10 dot network. Okay, I am getting 1 dot network, 20 dot network, 10 dot network over here. If I go on R2 and if I check show IP route EIGRP, I will be only getting 10 dot network. R3 is receiving all the routes learned from R2, but R3 is not sending any routes, but R2 learns only network, that is 10 dot network. Okay, R2 only learns 10 dot network coming from R1, but no EIGRP routes are learned from R3 because we have configured EIGRP stub receive only configured on R3. Okay, understood. Now we can do it in another way also. We can do it in another way also. Just give me a moment. Okay, now we have what we have done. We have done receive only routes. What we have done over here, we have selected received routes over here. Okay, we have set on R3 that whatever the received routes are there should be shown over here. Okay, so it should not be advertised over here. Okay, now we can configure EIGRP stub on R3 allowing to send only connected routes to R2, but R2 receive any routes from R1. So we can configure it in that way also. So like if I remove this thing, I can say EIGRP stub and I can say connected. Okay, so it will only advertise connected route. So if I see over here show IP route EIGRP, okay, let it get converged, show IP route EIGRP, the connected routes that are getting advertised to R3. Understood? We can configure as per our requirements as we want. Okay, so we can configure EIGRP stub allowing only summary routes. Okay, so now we can configure for summary routes as well. If I remove this thing and if I say EIGRP stub summary, only advertise summary routes. Okay, EIGRP stub summary. Okay, now if I go on R2 and if I check, I'll only get the summary routes over here. I'm not getting the 30.network. Like we can do different ways. In different ways, we can do these things. Okay, understood? Any questions? Okay, let us take 5 minutes break over here. All the things. Now here we have completed our EIGRP topic. Okay, there is not much in EIGRP. Okay, understood. So no one else is replying to my questions. I think so they are busy in their work. Now to summarize a network, I have given you the summarization over here. That day I have shown you the summarization. Okay, so we have disabled over here the summarization. Now to summarize our network, what we need to do? Now we have configured EIGRP on R1, R2, and R3. Pawan. Okay, I'm only using R1, R2, and R3, and I've configured R1, R2, and R3 with loopbacks also. Okay, and I've summarized the R3's WAN network. Okay, R3's loopback network.
Okay. Class 22.
Okay, I have just done the, you can see on the output show IP route EIGRP I have given on R2, and R2 is getting the routes that are summarized now, routes of 13.network.
Okay.
Okay, I will remove the stub configuration that whatever I've done over here. Okay, now I will get all the routes from 30.network, 10.network, and 13.network. Okay, I've configured EIGRP. Okay, I can see if I see show IP EIGRP neighbors, I'll have one neighbor over here that is my R2's router. Show IP route EIGRP. If I give here, I'm having the all the routes 30.network, 2.network, 20.network, and 13.network. Okay, on R1. Now, if I want to summarize the network, now when doing manual summarization or auto summarization, in many routing protocols, except in RIP, okay, except in RIP, the router doing the summarization will add a local summary route to null zero, also called as discard route. Okay, whenever you are doing summarization, except in RIP, it will add a null zero route. Okay, or you can say discard route. So this feature in place to prevent routing loops. Why we use null zero? To prevent routing loops. Okay. Now each routing protocol that implements the feature does so similarly, but each has some unique ways of preventing the discard route from entering the routing table, if that is the desire of person configuring it. Now here with EIGRP, now once we have already summarized R3 send routes as summarized route, auto or manual, you will see a route inserted into the routing table for 13.network pointing to null 0. Show IP route EIGRP. See, it is pointing where? To null 0. Null 0 over here. This is what this is to prevent the loop. Now to test and verify, let's try to ping any of the network, that is any of the network, like suppose 13.5.5.5, suppose, okay, which is not present on R3, but still it comes in the range of 13.0.0./8. Okay, so first we'll configure an access list to see, to permit a network. Suppose I created an access list and I'll say permit IP host 1.1.1.1, destination host.
Just one question. You did here manual summarization with
Yes, I've
/8?
done manual summarization over here.
Okay. Otherwise, auto summarization could take in other prefix value, right? Not 8. It could take other value,
It
maybe
could take
20,
anything. It could take anything
20,
like
21, the best prefix, right?
yes, the best prefix.
Okay.
Okay, now I will create an access list and I'll permit the host. The source is 1.1.1.1 and the destination is 13.5.5.5. Okay, and here I'll debug. I'll enable some debug packets, debug IP packets, and I'll say for access list 100. Okay, for access list 100. Okay, and also I will debug IP ICMP. I'll say debug ICMP packets. Okay, now I will see show IP route EIGRP. If I see show IP route EIGRP, I'm getting the 13.network. You can see over here 13.network I'm getting over here. Okay. Now let me go to R1 and try to ping 13.5.5.5.
Zero.
It is not getting ping. Okay, it is not getting ping. Okay, now if I go over here on R3, here I have done the manual summarization. I'll remove this manual summarization and I'll say interface serial 3/1.
No ICMP packet came here.
Yeah, just a second. I'll remove this thing. What I'll do, router EIGRP 100. I'll say auto summary. Show IP route EIGRP. See, here I'm having the 13.network as /8 over here and it is pointed to null 0. Now if I try to ping, here I'll get the ICMP packets over here. You can see I'm getting the ICMP packets and they are pointed to null 0. See why they are pointed to null 0?
Because this network,
This
IP
loopback is not there. This loopback is not present in the router. So that is the reason I'm getting this
It
as my.
it may be the client IP, right? Not only loopback.
Yeah, it can be anything. It can be anything. Loopback we use for testing.
Okay.
Okay. Loopback we use for just testing purposes. Okay. So here I am testing the things that 13.5.5.5 is present or not. So where is it? Where it is pointing? It is pointing to null zero, so that it cannot form a loop. Okay, so it is preventing a loop to be formed. Okay, so now I'll remove. I'll turn on this undebug all. Okay, now I'll remove the access list also. Suppose no access list 100. Okay, and I'll say I'll configure all the router to disable auto summary. Okay, so I have enabled auto summary over here. I'll say no auto summary. No auto summary. Rest all the routers are disabled with auto summary by default. Okay, so if I see the output over here, if I see show IP route EIGRP, I will get 1.20 and 10.network. If I see on R2 show IP route EIGRP, I'll get my 13 individual routes. You can see I'm getting individual routes over here for 13.network. Okay, let's just a second. I will connect a charger.
Okay, this is your battery running low. I thought
Yes,
my
yes.
battery is running low.
Okay, so I'm getting individual routes over here on R2. Now I'll configure R3 to perform manual summarization. Okay, I'll say that 13.0.0.0/22 after calculation. Okay, so we have already calculated. Okay, and we'll say that R3 should only give the summarization. So I'm showing you this thing again because you are not there. So I'll say interface serial 3/0, sorry 3/1 on R3. I'll say whenever you are sending the routes, send the summary routes for the loopback. So I have to say IP summary. Then in EIGRP, what is the autonomous system? 100. Okay, and what is the summary address that I got? 13.0.0.0. And what is the subnet mask that I got is 252/22. Okay. Now if I go on R2 and if I check show IP route EIGRP, see I'm getting only a summary route. I'm only getting a summary route with /22 over here. Okay. So with EIGRP, once we configure a summary route command, okay, on an interface, and immediately you will see a route inserted into the routing table. Okay. In the routing table of R3, you will see a route inserted in the routing table of R3 that is pointing to null zero. Okay. Pointing to null zero. It is a loop prevention mechanism in EIGRP, as we have seen in the previous task also. Okay, so we can see, we have verified in the previous task. Now we can create some loopback interfaces on R3 with some addresses. Okay, so I can check for more details. I can check, I can perform other tasks also over here. Okay, understood? There are many ways to check. I can create other loopbacks. I can change the AD value of the summary address, and I can do many such things to check the summary routes. Okay, understood?
I will go through this video. Maybe some have confusion. I will go through this video.
Okay, no
Recorded.
issues. Okay, so here we have completed our EIGRP topic. You have seen the EIGRP summarization also. Okay, so we'll stop over here for today.